First, we are going after energy intensive CNI segments, so the likes of, say, mining, data centers, 24/7 facilities, on manufacturing end, etc. Our proposition to them is very simple, that if you are already deploying, say, solar and wind for renewable, and that is intermittent, that is for 5 to 6 hours or 8 hours a day. Yes, you over deploy your renewables. During the day, you power your facility directly with renewables as well as charge our batteries. And for the rest of the day, our batteries will take care of the load. So essentially, you can actually get 100% renewable energy while also saving money on each and every unit of electricity you consume.
Hi, wherever you're joining me, I hope you're doing well. Welcome to India Tech Report, a platform dedicated to chronicling and supporting the growth of India's deep tech and climate tech ecosystems, one conversation at a time. I'm Hari, and in this episode, I'm joined by Priyansh Mohan and Stuti Kakkar, school friends turned co founders at MEINE Electric, to talk about their innovations in developing iron air battery energy storage systems for long duration energy storage. Renewable energy in India faces a fundamental problem of timing. Solar panels and wind turbines produce electricity when nature dictates, not necessarily when industrial factories require it. For the green transition to succeed, power must be stored for the long hours when the sun is down or the wind is still. While lithium-ion batteries serve shorter durations, they remain too costly for day-long storage as of now. Priyansh and Stuti are innovating in the area of controlled reversible rusting with the aim of providing energy storage for 16 to 24 hours at prices lower than with current options such as pumped hydro storage and, of course, lithium-ion batteries. Their approach uses materials abundantly available, iron, air, and water, to avoid the complicated supply chains associated with rarer metals. In this episode, we get a peek into the engineering innovations behind their technology and some of the challenges that remain in the way of building deep tech companies from India. Backed by Rebalance, Antler, Venture Catalysts, Grad Capital, and Anna Incubator, Stuti and Priyansh have recently raised a pre-seed investment for their venture. They expect to showcase a pilot-ready version of their first product as early as later this year. So, Stuti, Priyansh, thank you both for making time for this. Really looking forward to this conversation with both of you. You all have already done a lot of good stuff, exemplary work at MEINE Electric. And yeah, I also want to ask the correct pronunciation of the name, and I'll get to that. And I think you had a chance recently to address a national gathering where the Prime Minister was present. You've been recognized by DST and NASSCOM. So fantastic to have both of you on India Tech Reports podcast. So to get started, let's start with a simple backgrounder. Give us a sense of how you got the idea for this company. I seem to recall I read somewhere that initially you thought of building an EV motorbike, and then you zeroed in onto a battery, and it struck me that you guys are from Chennai, and Ather started in Chennai, and they started with a battery, and they went in the other direction, and they are now making scooters. So interesting sort of an anecdote over there. Okay, I will stop talking. Over to you. Just tell us the story of how you started this venture, and we'll go from there.
Sure, Harry. So it's a very interesting story and a very interesting journey that we have had. So me and Stuti was still in college when we started having the discussions about, can we develop a firm together? What can be what? And Stuti and me were school friends. We are both from Delhi. And I had come down to Chennai to pursue my engineering from Anna University, College of Engineering, India. I did my mechanical engineering from there. I minored in material sciences. And I was working on hydrogen fuel cells for electric vehicles. And before that, I had worked for a small amount in our research lab under my HOD with vanadium redox flow batteries and the flow systems of the same. So material science and the cusp between material sciences and process engineering is what I was working on. Stuti, on the other hand, was pursuing economics from LSR Delhi University. She was in her final year and she was about to get into BCG. She had gotten placed. And we were just talking, and I was like, okay, we'll develop, and I want to develop a motorcycle. I want to put a fuel cell within it. I want to boost its range. And that was like the very, very early idea that we had. And it really, came up as a college project. I was like, this is cool. I might make this into a startup. I registered the company in 2022. But the broader play for electric vehicles was, getting a little bit sour for investors and their investment theses. So I was just thinking and thinking, and by that time, Stuti was already in BCG. It had been like 6, 7 months for her there, and she had started working on energy and finance cases. And her primary work was in BESS deployments within India and Europe. So we started talking again, and this time I was very, very particular that EVs might not be the right thing, but I do like batteries. I have developed them before, and that's when this clicked with Stuti, because Stuti had that experience of yes, batteries are huge. We have only focused on short duration storage. There's going to be a long duration storage in APAC pretty soon, because it's already there in US, it's there in Europe, it's going to come to India. So why not, let's start thinking on those directions. And that's when in 2023, we decided to put the foot down fully into the battery space. We already had zeroed in on the exact chemistry we wanted to work upon, metal air chemistries, and started developing them. The first cell that we prepared was a primary cell, aluminum air fuel cell. And then we were like, okay, let's make it rechargeable. We started developing the iron air units around a couple of years back now. And yeah, since then, I think we have done a lot of good work, and it was primarily due to the insights that Stuti brought from the overall space that we need to build something for stationary storage, long duration, and I was just sort of there building the technology, so it kind of became the right thing and the right place to be at the right time.
Yeah. And like, so again, it was more of a journey of me trying to figure out what the market needs and where, where we can build a business versus Priyansh figuring out what would be the right technology for it. And it somewhere, converged to the concept of iron air batteries. A lot of things like, capacity, cost, supply chain is something that we, talked in depth about in our early days, because at that time you were seeing the rise of lithium ion, the supply chain was very skewed, geopolitical risk exists because even today, most of it is imports from China. The conversation was also around, can we make something with the India first supply chain? Can we make something which gives the longest duration of energy storage at the least cost possible? And that's exactly where iron air fit. Currently, we are building the technology for 16 to 24 hours of storage because, given the amount of renewables in the energy mix, that's the sweet spot that we have identified after speaking with customers. But the technology inherently has capability to be as long as 100-hour storage solution as well in the future when the renewables scale to say more than 50 to 60%. And that flexibility gives us like that extension of the market as well. So not just building for the needs of the grid today, but also building it for the needs of future. And the reaction is very simple. It's iron air battery, so it's at the core of it just reversible rusting. We have all know that iron rust. It's not a reaction that's unknown to humanity, but to do it in a controlled fashion at a greater efficiency, so it acts as a battery, is where our innovation and our and the overall magic lies. And of course, Priyansh can talk in depth about the tech.
And the name of the company, is it an acronym, MEINE, or is it just mine? How do you say it correctly?
It's Mine Electric, and like there's a simple story behind it. The original vision for the company, also when we decided we are going to build in this LDES space, was limitless renewable energy, essentially equitable electricity for everyone, cheap electricity. And while we were thinking, I was like, what's better than this? Calling it my electricity, right? If it's cheap, it's reaching millions of people in the future, billions possibly, then it should be everyone's electricity. So mine electric.
Okay, okay. So let's dive into your product and tech a little bit now. Your company is 3 or 4 years old now, or is it longer?
3.5 years registered, three actually working on the core tech.
Okay. So, where are you at? Do you already have a close to commercial product out there, or give us a sense of that?
We have our MVP, and that's our multi-kilowatt iron air unit that we are developing right now, which is going to be showcased in around a month's time. So let's say March, April 26th is when it's going to be showcased to a lot of folks. We have the core of the chemistry de-risked, core of the battery essentially de-risked. And right now we're in that stage where we are signing on pilots. We are having the first commercial discussions, making our first qualified leads pipeline. And by 26 end is when we are going to have our first pilot deployments, and 27 is all about proving, firming the batteries while they are in pilot and scaling up our operations also. And by 28, we should be in full commercial swing.
And you mentioned initially you also worked on aluminum air batteries
Hmm.
for a bit. How did you eventually sort of finalize on the iron air version?
So I think this was primarily because of the customer inputs. One of the things that we have done very well is since the inception of the company, we have talked extensively to customers. A lot of them became our mentors also later on in the journey. So we knew LDES is the space to build because the customers were talking about it, right? The overall policy was talking about it. So we were like, okay, let's start thinking in that direction. We bought out aluminum air as the first product to build because it was a relatively simpler product to build. It's just one discharge cycle, right? It's like a generator. It consumes aluminum in the electrochemical process. And we made a POC, not an MVP, but a POC really, and we showcased it to customers. And we asked them to come and see it, and we showed them the techno-economic analysis behind it. And the customer feedback was, see, you've done some great work. It is really cutting edge. But the cost economics is not making sense to me because every time I have to replace the aluminium. But if this was rechargeable, then the story shifts because it's a very, very cheap battery. And if it gets rechargeable, that means the OPEX is also almost nil, right? So can you make it rechargeable? And this wasn't said by one customer. This was said by almost 20, 30 people we had talked to. And that's when we were like, okay, maybe that's what we need to focus upon. Let's not chase the energy density, but let's chase the rechargeability of the system. So we had the core chemistry, which is the air breathing part of a metal air battery, figured out. All we had to do was work on the rechargeability aspect, and that's where like the last 1.5, 2 years of R&D has been. So if I'm missing any point.
No, so largely again, it was can we make the system rechargeable? We realized that within metal air family, doing that with aluminum air is not really it's a very energy intensive process to get it rechargeable. And this, physical replacement of aluminum plates will also be a hurdle as we scale the system. Because imagine a megawatt or gigawatt level plant, it's really not possible for you to switch out the plates after every cycle. So we looked at which metal like chemistries can be made rechargeable because we had the cathode already figured out. The cathode that we have developed is essentially a carbon nanocomposite membrane, so that acts as the artificial lungs of the metal air system. As Priyansh mentioned, taking care of the air aspect, giving the oxygen in for the reaction to happen. What we had to figure out was, the anode then that is rechargeable, and we realized we can do that with iron. Plus, because we had already worked on aluminum air batteries, we had developed really good basics on how a metal air system performs, like in not just in terms of the cathode, but the cell architecture, the overall subsystems that are required, electrolyte, etc. And most of that was, just transferable, and that's why we were able to then build upon iron air systems with all those learnings and in a much better fashion. So yes, and iron air makes a whole lot more sense. It's easier to scale. It's much more, effective in terms of the cost, the techno-economic analysis, and so on and so forth.
I want to ask about why it's more suited for scaling. But before that, again, keeping in mind the general audience, can you give us a sense of how the battery actually works? I mean, I have a simple understanding, maybe even just a simplistic understanding that the iron basically rusts and gives out the energy, and you have a way of reversing that rusting. And but let's hear it in your words in a better way. Tell us how the battery works.
So you got the crux of it. It's a reversible rusting process. The real magic within the system is how to control the rusting and how to then control the reversible part about it. So usually when you talk about rust, you are talking about magnetite, which is Fe3O4, which is that heavy rust which you can rub off, and it comes off the metal and it's just corroded. It's not useful anymore. Now think about a battery. You have an electrode. If your electrode keeps shedding material, after a point of time it's going to be useless, and if it's not on the electrode already, and if it has shed off, then it cannot be reversed back, right? So the primary work which we have done and which we have done is how to keep that before that magnetite state continuously for the whole discharge period. And if you can keep it there, then you can uniformly rust the whole metal electrode without the actual rust falling off, so that once you pass electricity through it, that flowered rust structure goes back into metal format, and it releases the oxygen that it had stored, the essentially corrosion it had stored, without really giving out any, shedding any material from the electrode. So yeah, that's primarily the reaction, and it was a lot of material science work that we had to do on an electrochemical level. So that's the primary thing. It's material science is happening. It's flowering, deflowering of the metal surface. It is the metal becoming heavier, then it becoming smaller again. So there's a lot of memory effect involved. We worked on electrochemically to make sure that memory effect does not come into play, so that this is not something that happens 3-4 times, but 3 to 5,000 times. So that was the work that we had to undertake. And yeah, that's honestly, apart from that, there's also the fact that if you dip a metal body into a water body, it will rust extremely fast. We had to find a way of electrochemically, not physically, isolating this metal that we are the iron which we are inserting into our water based electrolyte, so that it does not it will still rust but does not rust extremely fast, so that it's not like it's losing all of its electricity in a day. So right now we are at 2 to 3% self degradation a month, which is almost better than lithium-ion batteries, which are the best sealed chemistry on the planet today. So that was the work. That was the sort of work we had to do early on. And once we had it figured out, it was about scaling up the processes. It was about making the cell body. It was about making it into a product format which can be sold. Because I cannot really sell this stuff which I have in lab. There needs to be from lab to pilot to production and to make mass production scale up. So we are in that currently that pilot phase.
So, in some of these processes that you explained, including the engineering involved that is going to come up now, uh, can you talk about what is really proprietary? What is the real innovation? I mean, you have just mentioned it that you're controlling the rest part. If you can dive into that, give us a sense of what is truly proprietary to Mine Electric. Maybe you've patented some of these things and so on.
So we have 4 patents and we have 7 more filed, and almost every quarter we have more filing. So we track this quarterly now. The primary proprietary part about the work which we have done at Mine Electric, it is three things. First, we are able to charge extremely fast. Because of this isolation of electrodes that we are able to do, we are able to charge this battery as high as in 5 hours, which in traditional terms for iron air batteries it's unheard of. Usually the charging happens in 75 hours. This 5 to 8 hours of charge, what it enables for us is we can actually match the solar duty cycle. So when solar is available, we are able to charge. We are able to absorb a whole lot more electricity than any other battery of an LDS, space would have been able to. So a lot of capacity is able to be absorbed. So fast charging is one thing. Second is the air electrode aspect of it. This gas diffusion electrode which we have developed, so that oxygen from air can come in. And it's a basic enabler for metal air chemistries, and this has been done differently by every a metal air company out there on the planet who has been able to make this, stuff successful. The metal air, whatever chemistry they have developed. So there is a proprietary angle to our system also because it was built in a silo. It houses an electrocatalyst, which is first of its kind, extremely cheap. The process of making it is also extremely unique. I think we might be the first company in the world to have done that procedure in that way for developing the air electron. And the third aspect of it is just how the cell behaves. So rather than making huge cells like some of our competitors have done, we have made this into a little bit of smaller units which can then be, they're easy to scale up, easy to manufacture, and then just easy to mass produce. So this DFM level of work which we have done is also extremely proprietary to our iron air cells, so the sizing up is easier. So yeah, three things: electrochemistry, material sciences, and then process engineering.
By DFM, you mean designing for manufacturability?
Exactly. Exactly.
Okay, okay, and I get that the real specifics might be competitively sensitive, but when you say that procedure in that way, can
Hmm.
you give us a flavor of what you mean by that?
Yes, usually the air electro development, as it has happened traditionally, is not role to role compatible. We have made the air electro development role to role compatible, which is first of a kind. And role to role compatibility, as you would know, is the basis of why lithium ion manufacturing happens at scale. So that's something we have been able to do, and this is being done for the first time for air electrode or a gas diffusion electrode development, very specific to metal air cells. Honestly, it's not for hydrogen fuel cells, it's not for anything else, but for metal air, key enabler.
Okay, Stuti, switching over to the business side of things a little bit, you mentioned one of the things that customers told you, and you found the sweet spot as the 24-hour requirement. Can you explain that a little bit? Your target customers, and why is the 24-hour cycle your sweet spot?
So, largely, we have two broad categories of target customers. First, we are going after energy intensive CNI segments, so the likes of, say, mining, data centers, 24/7 facilities, manufacturing, and etc., where the primary requirement is cheap electricity, but more importantly, reliable power. Right? Most of these companies also have captive power plants which run on coal, natural gas, for the sole reason that they get 24/7 electricity. And our proposition to them is very simple, that if you are already deploying, say, solar and wind for renewable, and that is intermittent, that is for 5 to 6 hours or 8 hours a day, yes, you over deploy your renewables. During the day, you power your facility directly with renewables as well as charge our batteries. And for the rest of the day, our batteries will take care of the load. So essentially, you can actually get 100% renewable energy while also saving money on each and every unit of electricity you consume. Because from the grid, industries typically would get electricity or for more than like say 7 to 9 rupees per unit. But with our system paired with renewable and the low cost of storage that we provide, you can get electricity at just 4 to 5 rupees per unit. So essentially, that delta is where your electricity cost as an operating cost item goes down. The second set of customers are ultimately large scale IPPs, independent power producers, anyone who is setting up huge solar and wind parks today, or grid, ultimately the grid, energy utilities, etc. And for them, iron air batteries essentially enable them to reduce their curtailment. Today, all of these huge solar parks, let's say in states like Rajasthan, Tamil Nadu, etc., are also wasting a lot of clean energy. That is called energy curtailment because during the day they have so much overproduction and the demand is not there. So they can't really supply it to the grid. They are forced to ground it or they are forced to sell it to the energy exchange at like just 0 or 1 rupees per unit, essentially at a loss. So if you have a mechanism to store excess power and then discharge it whenever the requirement exists, you can essentially, prevent your losses and increase your revenue. And at scale, what we see iron air becoming is like a core energy infrastructure asset. Today, how we see thermal power plants or pumped hydro storage plants play a role in, our energy grid. We see with long duration energy batteries like iron ore, it will ultimately end up as an infrastructure that is needed to balance out a renewable heavy grid. Coming to how we identified 16 to 24 hour as the window. So we looked extensively at the energy supply and demand curve, especially in India or other solar heavy grids in the APAC and Middle East region. What we realized is because we have solar abundance throughout the year on an average, unlike countries, let's say America or Europe, where they have a significant winter season and accordingly a larger reliability gap. In India, we know that for sure that sun will come up to tomorrow as well, even though there might be slight weather related fluctuation. So essentially, we want something in these grids which can charge relatively fast in the 6 to 8 hour window when the solar surplus exists, and then discharge for the remaining duration, right? Looking at all of these like past charts and the increasing renewable penetration as well, we realize that reliability gap today is 16 to 24 hours for India, wherein our renewable penetration in terms of capacity is more than 30%, and in terms of generation, it's contributing again 10 to 15%. Although, as with the renewables increase, because we are adding solar and wind at an amazing pace, not just in India but globally, I think solar and wind are two electricity sources which humans have added in faster than any other source of electricity. So, sorry, yeah. So essentially, as this renewable penetration goes, as renewable mix becomes 50%, 60%, 70% in the future, this reliability gap will increase further. And that will converge to a closer of 100-hour window. And that's where we see the beauty of iron ore, where I mentioned it's not just to serve the demands or the reliability gap of today, but also, increase its capacity alongside the increasing renewable penetration. So in 10 days, it can also be 10 years, it can also be 100-hour solution if you wanted to.
I understand that the curtailment problem is a global one, right? I mean, I think a lot of electricity is being wasted this way around the world. I mean, in that context, what is the current state of the art of the metal air batteries, the type that you are developing, and other efforts around the world? In terms of the knowledge and maturity of the tech, whoever has done it the most mature today anywhere in the world, plus the maturity of adoption. What's the state of the art today?
Hmm. So there is obviously there are two other big companies in the world who are working on iron ore batteries. One of them is already deploying their pilots, and they have a lot of commercial traction. So that company is Form Energy out of USA, and they're focusing completely on the North American utilities market. And they have raised more than $1 billion. They were founded in 2017. They are backed by Bill Gates and Breakthrough Ventures. So they're a big deal. And they're going after the 100-hour discharge model from day one, because North American utilities market is primarily wind heavy. So the main reliability gaps comes during the winter months where the wind is not really there, and you have that 4 day window that you need to cover somehow, otherwise the grids fail. So for that, from our understanding and from our own research and from the numbers they have published, they have pilots already in megawatt scale. They have a huge manufacturing facility, plus they have almost 200 megawatt worth of orders already signed. So they are right now in the process of just rolling out, and I think the next 3 4 years is about for them is just expanding and fulfilling the demand, which is growing by the way. Then there is Ore Energy based out of Netherlands in Europe, and they are essentially the plus one to Form Energy, but for the European Union. And again, a wind heavy grid, 100-hour solution. They were found in the same year as us, though they were found in 2022, even though we started research in 23. And they have just raised their 10 million euro seed round, and they have just made the first grid connected battery live within Netherlands. So on iron is those other two folks, and they are big and they're growing. And then there's the third one, which is us. We saw that it should come to APAC. We understood it has to be a daily cycling battery, and we liked what iron ore had to offer. And this whole USP about charging it faster, discharging it to match a solar heavy cycle is what we have. Apart from us, there are other technologies in the metal air space also. There is obviously Finergy out of Israel, aluminium air, deployed it in India, deployed it in Israel for defense applications. There have been some developments in zinc air also. There was Nant Energy, who I think Form Energy acquired in USA. But yeah, primarily the main technology which has gained funding, gained popularity, and gained PMF has been iron air. First with Form, now with what Ore is doing, and now with what we are on the way and on the cusp to do. Yeah, those are the competitors we have today.
And in terms of like just the maturity of tech adoption, I think energy storage is kind of the space which is attracting a lot of investment today. And there's a clear, demand signal or need signal for this because like the last decade for energy transition was about focusing on energy generation, wherein focus was how many more solar panels or wind turbines you can add. Post 2020, that problem or that bottleneck has shifted not just on how much more renewable energy you can install, but can the installed energy be used 24/7 and not just for you know not just something which is always guided by weather. Because in the energy industry, two things matter the most. First is the cost, second is the reliability. And any technology which can prove that, which can make the renewable energy firm and dispatchable essentially around the clock, asset is something that is, the bottleneck today, which everyone is talking about. And we see iron air and long duration energy storage as the way to go about it.
So, in your case, a close to commercial technology demonstrator is going to come out in the next few months. And by when do you expect to start shipping products to customers? And also give us a sense of when you say scale, what would represent a good scale for you and by when?
Sure. So pilots, we are targeting them by 26 and 27 starting. 3 4 pilots with marquee customers who we see also wanting deployments later on, and the actual commercial scale systems by 28 Q1 is what we have planned. That's where the main OKR for the whole team is right now. That's the mission for us today. And a good scale for us for the first customers and to do the first 1 or 2 orders is around development of a facility that can do a megawatt every 6 months, so 2 megawatts a year in terms of the power we can deploy. And if the when the first deployments are successful, then it's about scale up from that 2 megawatts a year to around, let's say, 100 to 200 megawatt a year facility. Whatever we learn during each and every step. So the facility we have today is our product development and R&D facility. We have batch production capabilities within the same. We can deploy around 5 kilowatts a month, but that's not enough. That's just enough for pilots, right? The next facility is this 2 megawatt facility, and the next facility after that is this 200 megawatt facility, and it grows according to the demand. The production will rise.
So the initial first product that you're preparing to launch in the market, can you talk about the capacity and give us a sense of what that capacity translates to in terms of its use?
So the first product that we are looking about launching is a 40 kilowatt battery. It's going to be housed in a 40-foot container or a 40-foot battery skid. It's a modular unit. It will have a capacity for the captive power plant use case, which is the daily cycling use case of around 720 kilowatt hour. And for the 24-hour use case, if someone wants them to just replace the diesel generator, just the DG set, then it's going to have a capacity of around 960 kilowatt hour while maintaining the same power. Uh, Economics are going to look. It's going to be deployed anywhere between $20 to $30 per kilowatt hour. We are still figuring out the BOM. From what we see, it's going to fall further. Uh, but yeah, it's the first time we are putting it into production, so we also do not know what might rise, what might decrease. So we are working all of those kinks out. But yeah, a 40 kilowatt unit, completely modular, can be scaled up according to the customer's need. Let's say you have a 1 megawatt deployment, deploy 25 such kits, and you're going to match that 1 megawatt load. That too with a full 18 to 24-hour coverage.
And Stuti, you mentioned supply chain right at the beginning. In India, is the supply chain mature enough for you to manufacture your batteries at scale? And I would imagine when you talk about scale, you're talking of hundreds of units, maybe.
For sure. So in terms of just the core raw materials that we require, it's largely iron. Unlike lithium ion, which requires rare earth metals and like a very complicated, manufacturing and complicated and controlled manufacturing with like clean rooms, dry rooms, you know, uh, heavy machinery, etc. For us, both the materials and the manufacturing process is very much streamlined. In terms of materials, we have iron, air, and water simply. Of course, there are much more nuances to it, but largely it is India first. Around 80 to 90% of our supply chain would be India for sure, and we are seeing this even at an R&D scale, right? India is one of the largest producers of iron ore as well. On the manufacturing side, we don't need such a controlled and expensive manufacturing setup like with lithium-ion batteries. It's very much akin to lead acid. So most of the machines, equipment, etc., is something that we have built on our own, where we face that okay, there is something not that is available off the shelf. So we see in both of these aspects supply chain to be a key factor, and that's why we have started working on it from the get-go. Uh, Key supplier partnerships for our core materials, raw materials on anode, cathode, electrolyte manufacturing is something that we are already developing. So that once we hit the scale, once we can fulfill those MOQ requirements, we already have the partnerships in place.
Sorry, just to clarify, when you say partnerships, these are manufacturing, contract manufacturing partnership?
Supplier partnerships, yes.
And in the longer run, or medium to longer run, what is the thinking on manufacturing? Is it important to make your batteries in-house with your own factories, or is it okay to give it to contract manufacturers, or even become more of a designed in mine electric kind of company? I mean, two parts to my question. You can take it maybe one at a time.
I'll take up the first half. So the basic thought is we need to manufacture this in-house because the proprietary stuff on the electrode which we have done cannot go out. It's the secret sauce to iron air batteries is what we have developed. So the air electrode, the iron anode, the electrolyte formulation, etc., needs to happen in-house, and there is processes to it. After a certain point, you realize materials you can put them under spectroscopy and you will be able to get what material has been used. But until you do not know the exact procedure, when to turn off the flame, when to put it for extinguishing, it's all of this. When the cooling procedures, all of this adds up in R&D, and we have developed a significant moat here. So at least the electrode development and the final assembly will happen in-house, and we can have a ratio to what we develop in-house and what we contract manufacture. We don't need to do plastic molding. That's not required, right? We don't need to make the power electronics in house because that's in itself a whole company, right? We can partner with peer folks, big companies which are already developing power electronics, and just interface it with their units so that later on we don't have issues with DC blocks, don't have issue with transformers, inverters, etc., grid tie-in. We can just work with their ecosystem. But this core battery, at least we have to develop it in house. Otherwise, we will lose the R&D advantage that we have.
And in terms of significant challenges from this point to getting to substantial scale, where you're more of a commercial company in production stage versus the R&D engineering stage today, what might be some of those big challenges for you?
Uh, there's two aspects to it. There is capital and then there is validation. A deep tech company like us, and there have been cases time and time again where after the pilots are done, there's the valley of death. Because from that pilot to the actual deployments, there's a lot of ground to cover and not a lot of capital to cover it with. So we understand that. We are planning it and how to go about it. We are still a year away from that, but we have structured the plans already. It has to be a very measured approach to going about with time and money and the exact set of milestones we want to achieve during that point of time. And the readiness needs to happen today. So that's what we are working upon. So yeah, capital and validation. How much money we can raise equals how much validation we can do equals how much time we have to prove ourselves. And we are very, very aware of the fact that we are a startup. We are not a conglomerate. So we have a limited time, and there's only we have a very limited mind space also as a company. So we are doing everything which is extremely critical to be done, and then raising more and getting the other stuff done around.
Essentially, some of the challenges that we foresee would be transition of all the processes that we have currently from a lab scale setup or semi-automated setup to what would be required at a production scale. And with chemistry, the interesting thing is that optimization would be required at each scale. Right now, if I'm using a 500 ml capacity equipment and I want to scale it to 5 liter, there would be changes in chemistry also that I will have to do so that I can use that 5 liter capacity. So that process scale up is something that we definitely foresee. The second, as Priyansh was mentioning, validation. So by virtue of being a long duration energy storage, when we are testing our cells and our batteries, one cycle is still 24 hours, like one day, right? And there is only to certain extent which we can fast track that testing and validation process. The only way we can sort of compensate for it is to develop enough testing infrastructure and capabilities so we can test multiple cells in different environments with different compositions at the same time, right? And then generate a lot of data from the same. So those are the places where we are already thinking about focusing. And then again, there's this concept of being the first in India and APAC to build this. It's definitely not going to be 100% effort of just Mine Electric, but a whole ecosystem that has to then understand and adopt iron air and long duration energy storage technology. To be honest, at a larger scale, we are still figuring out how to put lithium ion projects in terms of bankability, insurance, project, costs and revenues for just a 2 to 4 hour storage. And here we are talking about 16-hour plus, right? So we are accordingly working with partnerships across the spectrum, not just suppliers, which I mentioned, but also regulatory bodies, also customers, so that we also can spread awareness and educate the customers and the ecosystem accordingly, and build this ecosystem in India for iron air batteries.
Can you talk about this a bit more in the sense that what are some important gaps today in the ecosystem?
Right. So, as I mentioned, at scale, what we want iron air LDES to be is like a core energy infrastructure, which enables, as our vision is, limitless renewable energy, and which means, first, of course, proving the technology at a, more rigorous and robust environments. That is something that, any which ways we have in our product development timeline. But then for any other asset, there's the other aspect, which is whether it's a high utilization or a low utilization asset, what will be the cost at the end? How will it be tied with the grid? What are the policy and regulations and where they are pushing towards? So, we have the National Electricity Plan coming out. We have a lot of push from the government now to make renewable energy firm and dispatchable. But are there right contracts to, provide a revenue channel for such assets? Most because we are still figuring out a lot of these things on the battery space. Do the banks see and understand enough to provide the project finance for a, let's say, gigawatt scale battery energy storage project, and what are the metrics they are seeing? So it's a long process, and we are all, as an ecosystem, I think, working towards it.
And on the capital front, briefly, again, for folks who might be curious about this part, you all have raised some pre seed funding so far. Can you give us a quick update where you are at and what you're planning?
Sure. So we have raised around $750,000 in equity and around $100,000 on top in terms of non-dilutive grants from government and other agencies around the world. And all of this we are deploying currently for the pilot scale validation. And pretty soon we're going to make our seed round live, which is going to be in tune of $3 to $4 million or more based on how the market perceives it and how much validation we're able to do within the funds we already have. Uh, yeah, that is going to be for this facility development for actual pilot deployments and making the commercial intent system more robust. And then there's going to be the Series A. Uh, the quantum of which I would not like to say out right now, but it's usually in the deep tech industry in the tunes of $15 to $30 million between that, and it's scale up, right? It's a lot of money. We require more than your usual SaaS startups. There's a lot of capex investment that we have to do. There's no way, no two ways around.
Okay, one question Simply because I'm curious about this, and I'm not sure if it makes sense in your case, but is there a consumer opportunity for you down the line, or this is not a technology that's suitable for such applications? What is your view?
We are uh, we have not explored that from our side because we were B2B from the get-go because that's where we saw the primary impact coming out. But that's not to say there's not a consumer play to it. It's just that the market is so huge. The energy industry for LDES is expected to grow to $1.8 trillion in the next 15 years. Such a huge market has got to be segmented, and it was our job to choose which segment we had to go after. We chose energy intensive C&I customers because they are ready to pay today. Because for them, cheap electricity is a good sell any day of the year, right? And next, we wanted to go after grid operators and utilities because that's our way to actually cement the battery as a infrastructure class. The consumer play, on the other hand, might not be good for us today. But we are already exploring it. We are talking about it, and we are understanding how this market works. We don't know consumer. My background is technology, and I work for B2B technology. Stuti has worked for B2B in terms of the consultant and management consulting part of it. That's what our advisors also understand. The consumer industry, on the other hand, is a very different beast, and we're understanding how it works.
And essentially, there's also a need aspect, right? So, in India, how the power outage scene has evolved for most of the places that the duration of the power outage is not as long as it was used to be, even though the frequency of these outages might be higher. But these might be, let's say, a 5 minute or a 10 minute or a 15 minute outage. So in those cases, the current UPS or backup systems just work really well and are sort of the industry standards. Mostly people are using lead acid or lithium-ion batteries. And for those, quick duration power cuts or power backup requirements, I think that's more than enough. There's only a very small segment on the domestic, consumer side who would require a long duration energy storage such as ours. That's why we see a bigger market on the B2B and B2G side at the moment.
I just wanted to capture one other detail on the cost. You've mentioned earlier on somewhere about 4 to 5 rupees.
Hmm.
Was that
Per kilowatt hour.
per kilowatt hour? And
Yes.
just give us a sense of the comparison with what are the other things that are sort of valid to compare this with lithium ion or pumped storage,
Lithium ion,
hydro.
lead acid, pumped hydro storage. Yeah.
Uh,
So just in the storage space, there are only two technologies which are commercially viable today. There is pumped hydro storage, which is like 90% of the market globally for storage. And then there is lithium ion, which is 10% of the market. And everything else is in pilots. And none of them actually have big deployments, which can be accounted for in this 90 to 10% ratio. So pumped hydro storage works anywhere between 6 and 7 rupees per kilowatt hour, and lithium ion works anywhere between 6.5 to 7.5 rupees per kilowatt hour. And we are working at 3 to 4 rupees per kilowatt hour, and yeah, those are the numbers we are going to levelize around.
So this is levelized cost of storage. So it includes everything, the capex, opex, sort of augmentation required, the life of the system, the round trip efficiency, and then like club it all into one metric so that we can compare all the technology on a apples to apples basis. So levelized cost of storage is usually one of the key metrics that industry looks at to compare technologies. That is to say, we can also look at pure play capex, numbers as well. So today, lithium and DC block cost is around $50 to $60 per kilowatt hour. Whereas at scale, what we project because of the cheaper raw materials and the cost-effective manufacturing process, our DC block cost just in capex would be somewhere around $10 to $15 per kilowatt hour. And that in itself, in just the capex, is like a huge difference which we can claim for.
And also, one other point I wanted to understand better in your the way you have envisioned it or you've engineered it today. Typically, how long will one battery last before it needs to come back to you for recycling or to someone else for recycling?
So with the Gen 1 of the unit, we are trying to hit a validation mark of 10 years. And why 10 years is because we wanted to match the lithium ion batteries which are out in the market today. We don't really want our customers to go through that, plus minus cycle of, okay, if this battery is lower, that battery is higher, but it is cheaper. one is to one. It's going to last that much years, and that's the validation that we have internally today. But later on, as the Gen 2, Gen 3 of the product comes out, because this is a huge R&D play from our side, it's not like the R&D is going to stop with the first product. We want to hit in the future around 20 to 25 years lifetime from the overall battery pack. It's possible. That's because the theory tells it can be a 40-year battery also. So 20 years is possible. And why we want to do that is we want to match the solar cell life so that the whole thing can be shipped as one unit. The battery comes with it, the solar comes with it, and the transmission cables come with it. So everything, the whole plant can be banked together.
And I'm thinking you have again planned and engineered it to be kind of all weather. You know,
Yes,
the tolerances are from Rajasthan to whatever
yes.
Himalayas. And, okay, fair enough. Uh, I haven't actually covered defense tech a lot, but I'm beginning to understand, learn more about it. I mean, is that a separate segment for you? Requirements by, armed forces, strategic defense, and things like that, or is it broadly again a B2B kind of thing for you?
So that is someplace for sure we have got a lot of interest towards, and we are currently evaluating if our product can make sense for them as well. In their requirements, most of it is extreme, as you mentioned, extreme temperatures, longer life. So defense is definitely one segment we can look into. But that will largely open up once we have the basic validation and pilots already in place for the B2B sector.
Okay, I want to understand two things better. One is the longer term vision for the company, and deep tech companies longer term probably means 10 years plus. That's one, and the second is of course this year, next 18 months. What are your top priorities?
I'll cover the vision, so they will cover the tactical decisions and as we have set for the next 18 months. Uh, the overall vision for Mine Electric, as I mentioned previously, has been from the get-go limitless renewable energy. And our primary focus, at least for the next 5 years as we see it, and 5 years is how long we always plan, is we need to first have the first product, which is the first generation of the battery. And then we need to work on making that battery better. There's obviously the internal electrochemistry becoming better, the round trip efficiency becoming better, the overall swing cycle of the temperature the battery is able to withstand becoming better. But on top of that, by the year 2030, once we have our first commercial deployments in hand, we also want to develop a data layer around the batteries. Essential engine to tell where to deploy how much for the customers, right? And that can then be used to actually increase the efficiency of our batteries too. So that data layer, the thought process of the same has already been in our mind for quite some time. We are mostly going to do it post the pilot deployments are done. But if we do that, it will be first of a kind long duration storage data set that any company has. And then it can be deployed for our own use case and for others use case also, because for us it's as much as our own development as much as it for the ecosystem development. So if we can contribute towards it in a positive way, not just by our hardware but by our software work, then why not?
Yeah, and I think the focus for the next 18 months is for sure, deploying the pilots that we already have confirmed, drill down on, validation and data that, our systems generate, and see what learnings we can get from how the battery works in real life.
That's it for today. You can find the links to Mine Electric's website and the founders' bios in the show notes, wherever you get your podcasts. To support my work, please subscribe to my posts at indiatechreport.in. I'm Hari Arkli. Thank you for listening.